I'm going to do part 1 for my lab 2. We are required to investigate the operation of 74HC74D type flip fault for the following stimulus. This is my schematic of my temper switch. This is my circuits. My circuits consist of two input, which is D input and the clock input. The set and reset is connected to the VCC. This is my output Q. Then now I will demonstrate my circuits according to the question given. When the D is low and the clock input is low, my output is low. When the D is high, the clock input is low, my output is low. When the D input is high, clock input is high, my output is high. When the D input is high, the clock input is low, my output is still high. When the D input is low, my clock input is low, the output is still high. When my clock input is high, my D input is low, the output is low. When both of the input are low, my output is low. When D input is high, clock input is low, my output is low. When both input are low, it's still low. When both input are high, it comes to high. This is my result. Thank you. The part 2 of lab 2, we are required to draw the expected waveform for the circuit shown. We predict that the frequency of the waveform at X is 250 kHz. This is the waveform that we predict. This is my circuits. This is the output Q, which is X in this question. This is the input clock signal, which is 500 kHz. The Q bar is connected to the data input. So this is the observation from our circuits. Channel 1 is the Q signal, channel 2 is the clock signal. We obtain that the channel 1 Q signal is half of the frequency of clock signal. Thank you. Part 3 for lab 2. Part 3 requires us to modify the sequence of a 74HC161 4-bit synchronous counter so that it counts up to 1 to 6. We are also required to design the required combinatorial logic circuits. This is my logic circuit, reload logics. The reload logics consists of 3 NAND gates, and this is my circuit. This is
one action.
I'm going to do my part 3 for lab 2. Part 3 requires us to modify the sequence of a 74HC161 4-bit synchronous counter so that it counts up to 1 to 6. We are also required to design the required combinatorial logics. This is my reload logics. My reload logics consists of 3 NAND gates, and this is my circuits. This is the LED module, and this is my switch. This is 74HC161 4-bit synchronous counter. This is 74HC00 2-input NAND gate. Now I will start with low frequency. So this is 6, 1, 2, 3, 4, 5, and 6. My circuits will stop at 6, which is correct. And I will do it one more time. 1, 2, 3, 4, 5, and 6. In order to produce a random number, I will increase the frequency so that I will demo again. Okay, thank you. Of lab 2, we are provided with die module having 7 LED arranged in a die pattern. We are required to design a decoder circuit that takes a 3 bits binary number as input and produce the 4 bits output to drive the die display. This is the table that we have produced. When the count is 001, 1 will represent high, 0 will represent low. When it is 001, the A output must be high. When it is 010, the D output must be high. When it is 011, the A and D outputs must be high. When it is 100, the C and D output must be high. When it is 101, the A, C, and D must be high. Lastly, when it is 110, the B, C, and D must be high. This is the schematic produced from the previous table. This will be the circuits that we will be implement. We are using 2 NAND gates, which is 74HC00 as an AND gate for the B output. We are using two NOR gate, which is 74HC02 as an OR gate for the D output. This is our circuits. This is the 3 input, which is Q2, Q1, Q0 as in the table. Now I will demonstrate my circuits. When it is 001, the die number will be 1. When it is 010, the die number will be 2. When it is 011, the die number will be 3. When it is 100, the die number will be 4. When it is 101, the die number will be 5. And lastly, when it is 110, the die number will be 6. Thank you. Do combine of part 3 and part 4 to produce electronic dies. This is my circuits. This is 74HC161 4-bit synchronous counter. This is 74HC00 2-input NAND gate. This is 74HC02 2-input NOR gate. This is my die module, and I am going to start with low frequency. Okay, I will demonstrate my circuits now. This is 2, 3, 4, 5, and 6. This shows that my circuits will completely stop at 6, which is correct. And I will do it again. 1, 2, 3, 4, 5, and 6. So it stops. Now, in order to produce a random number, I will increase my frequency. So I will demo it again. 2, 1, 4, 4, 1. Thank you.